Today we will be talking about the basics of triangles. And just to review, we all know what a triangle looks like. But the legal definition, it's a closed figure with 3 line segments and 3 angles. That's pretty basic. We all know that. But now there are several different kinds of triangles. We can classify them, name them different things. Okay. So the first triangle that I have written here, we see that all of the angles are acute angles. They are all less than 90. So when they are all acute, guess what we call the triangle? This is an acute triangle. Okay. Now, in my second triangle, I have one obtuse angle. One obtuse angle. When I have that one obtuse angle, guess what we call the triangle? It is called an obtuse triangle. Got it. Wow, that's pretty tough. Okay. Guess what? We have a triangle with a right angle. I wonder what we will call this triangle. Yes, it is a right triangle. So, an acute triangle has all acute angles. An obtuse triangle has one obtuse angle, and a right triangle has one right angle. Now we can also classify triangles by their sides. Okay, this is classifying by their angles. Now we're going to classify them by their sides. If we have a triangle with none of the sides equal, okay, or we can say congruent. When a measure is equal, we say it's congruent. So that when the lengths are not the same, this is a weird one. It's called a scalene triangle. Scalene. Now say we have a triangle and I have 2 sides that are congruent. And when we put these little hash marks there, that means congruent. That means they have the same length. Okay. We call that an isosceles triangle. Isosceles. This is really weird words. Now say we had a triangle with all of our sides congruent. This one makes the most sense. This one we call equilateral. Equilateral triangle. Okay. So while naming them by the angles makes pretty much sense, naming them by the sides may not. Scalene has no sides congruent. Isosceles has at least 2 of the sides congruent. Equilateral has all 3 sides congruent. So now let's review a term that you probably learned in a previous course. That is perimeter. Perimeter. Okay. That is the distance around any closed figure. So the perimeter is the distance around. We add up all of the lengths of all of our sides, whether it is a triangle, whether it's a quadrilateral, any size, shape. So let's look at a reason why we might use this. Okay, so we have a triangle here. One of the sides is 4 inches, one is 3.2 inches. I want to, first of all, find out what this side is, and then I want to classify it somewhere over here. So I'm told that the total perimeter is 10.5. So let's think about that. If the distance around the whole thing is 10.5, this is 3.2 and 4. I think if I just add all 3 of these up, it's 10.5. Okay? So I am going to just say that P, I'm going to call that P for perimeter. And I'm going to name this X. I don't know what that is. So I'm going to say it is 3.2 plus 4 plus X, plus that something. So if I add these 2 together, I get 7.2 plus X. Okay? And we know that the total distance around is 10.5. So now we have an equation, a one-step equation. We can solve this. So what we can do is we can subtract 7.2 from both sides. And when we do that, we get 3.3 inches. Now, what we're wanting to do is to say, what kind of triangle is that? Well, let's look at this. When we're looking at our sides, we're going to name it here. Equilateral means all of our sides are the same. Okay, that's not happening. Isosceles means two of our sides are the same. That's not. So this is a scalene triangle because all of the sides are different. Let's do another one. We have a triangle here. One of the sides is 58 kilometers. One is 100 kilometers. We want to know what this other side is, and we know that our total perimeter is 231. So let's name this one X. So our perimeter is the sum of all of these. So 100 plus 58 plus X. So we know that the total amount is 231. We can add these together. 158. Now we can subtract 158 from both sides. Okay. That falls off. And then we are left with 73 kilometers. Now, if we were to classify our triangle, we have a 58, 73, and 100. All of those sides are different, therefore, it is also a scalene triangle. There is your introduction to triangles.